Hello guys, welcome back. Today we're going to go back to lesson 5. This is the lesson that you guys should have had mailed to you, so you have a hard copy of this lesson. But I understand, obviously, that you did not have uh, uh, any videos to go along with that. So I wanted to go back and make a video for this lesson because factoring these 5 lessons that we missed this week are super important. And I want to make sure that you guys get this down. So lesson 5 is on factoring. And my targets for the day are I can model and write equivalent expressions using the distributive property, and I can move from expanded form to factored form of an expression. All right. So jot that down in your notebooks. We're going to take notes just like normal. It's a really good habit for you guys to get into and enhances your learning. And then when you get done jotting this down, remember guys, if I move too fast, you can pause the video. All right, so take a moment, pause the video, jot down example number 1. Okay, I'm assuming that you've paused the video and you've had a chance to write that down. And example 1 says 3f plus 3g. Let me make that look more like a G. That's supposed to be a G. Okay. And example 1, part A, says, what is the question asking us to do? It's the $5 million question, right? So what we need to do is we need to rewrite the expression as an equivalent expression in factored form. Okay? So I'm going to write rewrite expression in factored form. Okay? The number outside of the parentheses is going to be our GCF. So what this means is the expression is written as a product of factors. Remember, factors are things that are being multiplied together, right? So the number on the outside is going to be the GCF of 3f plus 3g. Okay? And part B, right here, says, how would the problem look if we expanded each term? Here's term number 1, here's term number 2. Well, if I expanded 3 times f, or 3f, that would just be 3 times f plus. And if I expanded 3g, well, that would be 3 times g. Okay? So that's what it would look like in expanded form. Okay. What's the GCF here? Think about that. What's the GCF? 3f and 3g. Well, what's the greatest common factor of those two terms? How about 3? That seems to jump right out at me. Okay, and how can we use the GCF to rewrite this expression? Well, what I can do is I can factor out the 3. Since the 3 is the common factor in both of these expressions right here, both of these terms, I can just factor the 3 out. So, just like it said, what is the question asking us to do? It says the number on the outside will be the GCF. So the GCF we said is 3. And then on the inside, I'm now just going to write f plus g. So if I want to use the GCF to rewrite the expression in factored form, the 3, the greatest common factor, goes on the outside, then in the parentheses, f plus g. And if I want to distribute this 3 back in, right? So this would be 3 times f and 3 times g. 3 times f is 3f. Keep my plus sign. 3 times g is 3g, which is what we had at the beginning. Okay, so all we're doing is we're finding the GCF of our two terms and factoring it out. So if we take a look at our problem set, again, what is the question? It just says, what is the question asking us to do, right? The question is asking us to rewrite the expression in factored form with the GCF on the outside. So what's our GCF here? I got 6x plus 9y. Well, is there a number that can go into 6 and 9? Sure, it's 3. So I'm writing the GCF on the outside. Remember, if you can't remember how to find the GCF, we could do this. I could say, oh, what goes into 6 and 9? 3. That's 2 and 3. Can anything else go into 2 and 3? No, so my GCF is 3. Good. On the inside, well, let's see. 6, right, divided by 3 is 2. The x in this case is going to stay the same. 9 divided by 3 is 3. And I didn't factor out a y, so the y is going to stay in there. So I have 3 times 2x plus 3y. All right. How would this problem up here look if we put it in expanded form? Well, that'd be 6 times x plus 9 times y. Well, the GCF in problem 2, we already decided. That's 3. And how can we use the GCF to rewrite the expression? Exactly like what we did up here. I'm going to show you again. Okay. We found our greatest common factor was 3, right? So I've divided the 6 and the 9 by 3. I kind of pulled that 3 out of this original expression. You can think of it as I pulled it out. And then what's left inside is 3 times 2x plus 3y. I'm going to do a couple on the back here. So this is the front of the problem set. Here's the back of the problem set. Well, let's take a look at A. All right, A says 7x plus 7y. Well, what's my greatest common factor there? All right, probably that 7. So I'm going to pull that 7 out. And if I'm pulling it out, we had to make it look like there's something left on the inside there, right? So 7x divided by 7, I'm pulling it out, so I'm dividing. It's being multiplied, so now I'm dividing. 7x divided by 7, well, that's just going to be 1x. And 7y divided by 7, well, that's just going to be 1y. Okay? Again, if I want to show how this is correct, I could multiply the 7 back in by distributing. All right, and I could say 7 times x is 7x. 7 times y is 7y. Okay, let's take a look at one more. Let's take a look at E. Okay, what's my greatest common factor of 11f and 15f? Well, there's no number that can go into 11 and 15, right, other than 1. But what do these two terms have in common? How about that f? Can I pull that f out just like I pulled the 7 out up here? Sure can. Let's pull out our f. And if I pull out the f, well, what's left? I have 11 over here because I pulled out 1f. F divided by f is just 1. And if I pull out an f over here, again, f divided by f is 1, so I'm left with 15. Okay? And again, if I multiply that f back in, whoop, I'm going to get 11f plus 15f, which is what we started with. All right, I think that's pretty much it. I know that was kind of a quick lesson. Factoring is really important, so I want to make sure that you guys know how to do this. If you have any questions, please let me know. Thanks.